Hello everyone, Adam here again from TCT3Sixty, and this time we're at the Fetus and DropEffect booth to talk with Max from DropEffect. So Max, can you start off by introducing yourself and what you do and what DropEffect the business is all about?
Yeah, sure. So DropEffect was founded back in 2019 with the aim to market an extruder called the Omni Drop. And that extruder was like very compact, and the main aim was to print flexible materials very reliably. We achieved that. And then over the last few years, we talked to Fetus as a supplier for certain components, like a heat break was supplied by Fetus. And over the time, we developed like a relationship, obviously. And in the last year or so, we talked about working closer and closer together, but at some point you have to decide, in what direction you want to go. You can't divulge everything and all your research. So at the end, we decided to work together and merge those two companies together now.
Okay, so DropEffect, Fetus sort of becoming one thing, or is that more of a collaboration? What's the deal there with the two businesses?
Yeah, good question. So actually, to be very clear, Fetus basically purchased DropEffect. They have a majority share now. However, we do still work kind of independently. So our aim at DropEffect is becoming more and more research and development. Fetus is more and more production and mass production. And we research also fundamental principles in the extrusion process. So we want to figure out certain processes, and from those processes we want to derive new kind of products. Instead of developing just new products, we want to first understand more and more the process, and from that we want to derive new products.
Okay, that's great. I'm definitely all about investigating and improving the process. So it's really good to see Fetus like investing in that R&D and generating new ideas, new product with yourselves. So what are the new things that are coming like from this collaboration, this new partnership between the two?
Yeah, so there are in total three I want to present today. Let's start off with the smallest. That's the XG Hotend. The XG Hotend was already developed, or we started developing already last year before the partnership, but Fetus really drove home basically, or put it to the home stretch, because there were certain factors we want to achieve we didn't quite, and Fetus just gave this little bit of input that helped us, put it where we wanted to. So it's called the XG Hotend because it's called Extreme Gradient Hotend. We wanted to achieve like a really, really sharp temperature transition. And how can we achieve this? Is we use this ring heater basically right here, which is kinematically coupled to this frame, this whole frame. And because it's kinematically coupled, there's very low temperature transition. So there's point contacts instead of surface contact. So we have less heat to dissipate. And this enables us to bring the heat sink closer and closer to that ring heater, and making then as such the temperature transition very, very sharp. Which means that at the entry point, where the nozzle now finally is the complete melt chamber, instead of before where we combined the heat break also as a melting part. And with this smaller nozzle that goes all the way basically up to that heat break, we can ensure that the temperature transition is sharper, and this also, don't want to promise that, but it's more leak proof. It helps definitely, because at that temperature transition, it's about 100 degrees. That means as the filament enters the nozzle, it's 100 degrees, and then very sharply pushes up to the temperature you want on your hotend. And this ensures that the filament doesn't melt before it's actually inside the nozzle itself. So we wanted to separate the functions of the heat break and the nozzle, and that is the aim.
So with that kind of kinematic coupling and reducing the transition of thermal energy from the hot part of the hot end to the cold part of the hot end, how are you achieving that? What does that really look like? What is a kinematic coupling?
Oh, yeah, so sorry about that. Yeah, kinematic coupling basically is the same thing that also E3D uses on their tool changer, for instance. It's a system where you can mount with 3 points very accurately any kind of plate or any kind of system. So they're connected strongly together, yet they have very little contact actually with each other. So it's like an X shape, or a T-shaped, Y-shaped actually, to be honest, sorry. It's a Y-shaped form, and then basically you use balls that connect them into those Y-shaped grooves. And these Y-shaped grooves make like very small contact areas. To actually also say, to reiterate how the heat enters basically the nozzle, is that we use an M4 thread. I know people are now a bit anxious saying, okay, another standard. We didn't want to change the standard. It's not something we wanted to change, but it was intuitive to do so because we use 1.75 millimeter filament. It's a small filament diameter, and using a thinner walled with an M4 thread, we can ensure that hardened steel nozzles also transfer more heat into the filament. And with an M6, you have such much material that the temperature transition into the filament takes longer and is slower. So we changed that, and we invite any manufacturer to use M4 threads as well. We don't have a patent or anything on it, it's just because we wanted to achieve a better performance, that's all.
Okay, so that's good to see that kind of thing that maybe a lot of people had not recognized, that the size of that thread and the size of the nozzle can impact that thermal transition. So it's good to see that aspect being addressed, although hopefully nobody has to buy too many more new nozzles.
No, exactly. Yes, we don't hope so. We will start instantly with hardened nozzles, and the standard will be copper nickel plated nozzles from the start. So you will have both optimal systems, a high temperature transition material like copper nickel plated on the nozzles, and hardened steel as well, for these abrasive filaments.
So the next thing I noticed about this is the thermistor looks a little bit non-standard or different to what I've seen previously. Can you talk about to what end or why that is?
Yeah, one of the issues we had with cartridge-style thermistors was that you secure them with a grub screw. And the problem with grub screws is that you cannot tighten them very strongly, because if you do, you crush basically the thermistor. And it's very difficult to convey force verbally or in a text and saying don't tighten it too much. Everybody has a different kind of sense of force in their hand. And so we decided we want to decouple this kind of system from forces that the user has to apply. So we use this kind of M4 threaded thermistor, which you can screw in here on the side, so it's replaceable. So if something breaks, which happens sometimes with thermistors, we all know that, it's easy to and fast to replace.
Obviously, in terms of how hard you tighten something down, we have torque ratings, but how many people at home have something to measure that? So it makes really good sense to have something that, as long as it's tight enough and it's secure, then that is the right amount. You don't have to go, oh, not too much, not too little. Oh, no, you broke it. You've got to get another one. So that's really good to see. So what about mounting options then? How can we mount this? What's the deal there?
Yeah, good question. So that's one of the key also issues with any kind of hotend. A lot of hotends come with a singular or maybe two mounting options. We wanted to expand that a bit more. So we have obviously the groove mount option, we have an Orbiter version 2 mounting option, and we have a Creality mounting options. However, they're not coupled to the frame. So these mounting options, like the groove mounts, are bolted down from the inside of this frame-like structure with screws. So by removing those screws, you can decouple it and then attach basically the Orbiter or the Creality, and we want to expand even more. The standard version comes with like a Voron style 11 millimeter square M2.5 threaded inserts here. So you can mount it basically from the top, but let's say you want to groove mount, you can get this additional add-on, or you want the Orbiter, or you want the Creality. So you can change this hotend to any kind of printer you want. So
yeah, that's good to see that if you did want to move it from one printer to another, or you're upgrading from a Creality and maybe modifying it into something different, you don't need an entire new hotend. You can just buy the new adapter and move it to that new style of mounting. That's really good.
As well on this hotend, you have a very small fan. It's 25 millimeters, 10 millimeters in width. And so it's a very small and quiet fan as well. So that's also one of the key features we wanted. It's not only that you have a very sharp temperature transition, but you can blow a lot of air over it, obviously, and you put a big fan over there and you get also a very sharp temperature transition. But the real problem is getting a small fan to do to get these properties. And that fan is really, really quiet. And that helps, for the sound of the machine, because people are looking for quieter machines.
Okay, great. That's excellent. So what else have you got that we can take a ganders at?
Yeah, so let's go for the Fetus one. So Fetus, the second biggest one is the Fetus Extruder now, the Apis Extruder. That was a challenge in its own, because Fetus obviously wanted an extruder for their kind of hotends, which is understandable. You want to have a complete extrusion process in-house. And so we worked on a system that needed to be all metal, but needs to be compatible with all these hotends. So how can you achieve that with all these different mounting options? So we decided very easily to say, okay, there's going to be a 3D printed part, and that's going to be the only 3D printed part, and the user can print it themselves and then attach all their hotends to that. So this mounting of this 3D printed part is secured by 2 screws right here. And by removing two screws, this whole block with the hot end comes out. And we try to maintain a so-called 3-screw system. By removing 3 screws, you get access to the whole filament path, just in case something goes wrong. So those 2 screws from the hot end, you remove them. The hot end is gone. You remove the idler spring here. And then you have access to the whole filament path. And it's very constrained in total. So also, since these files are going to be available as a step file, you can even change them and even more constrain it if you think it's necessary to do so. So you can change this whole constriction and change it to any kind of hot end, not only the Fetus ones, but other hot ends as well. We have a very small NEMA 17 stepper motor on there. As people might know, they get very hot if you put a bit of more current than they should. So since this is an aluminium frame, it dissipates the heat over the whole extruder. And so we can push 1 ampere into that motor and it still stays warm about 40 degrees. So you will not burn yourself and the whole extruder won't warm up as well, so don't worry about that. So what else is there? We have a manual wheel, so that is quite nice. So you can load and unload the filament quite easily.
Without scratching your fingers on the gears?
Exactly, that was the other option because we thought about, okay, let's leave that away, keep it even smaller, remove that and we have the smallest extruder or thinnest extruder on the market. But in the end, user convenience is also key for us. We just don't want to make it smaller and smaller and then leave out the user-friendly design in it. So we have a manual wheel on there so it's easy to use. And yes, it's possible to do so, as you can see, but it might be not the most comfortable thing to do.
Yeah, I guess performance isn't everything at the end of the day. You have to still be able to use it. If you can't use it, it doesn't matter how good it is. So it's good that you've considered that.
Yeah, and one also very important feature as an engineer, as you might know, we have our little things we want to achieve, is the center of gravity of that whole extruder. So the center of gravity is basically roughly round here. So the mounting is 2 screws here at the bottom, which you can see they are loose, and it's an aluminium plate which you can bolt down on any kind of system, and that system is secured by 3 screws. So one here and 2 here. And if you remove that, you can attach it and then put on the extruder, tighten those 3 screws down, and it's fixed. And the thing is, which I like really a lot about this, is that the center of gravity is roughly around here, which means that if you secure it, your system will be, your momentum which this extruder has on your fixing point is very close to it. So you won't have like this flinging effect, It's like if you have it like bolted down there, you can feel how the extruder falls away from you. While if you hold it down there, it's very stable. And also if you attach a hot end onto it, the center of gravity moves roughly down here. So it's always very close to your mounting system, which was for me very important to keep that distance very close to it.
Yeah, so obviously in terms of the moments and the faster you print, the faster accelerations you start driving in, the more that kind of center of mass becomes important to make sure that your extruder's not wobbling around all over the places you're trying to print.
Exactly. So that's one key aspect what I really looked at when designing this extruder was to get really that center of gravity close to your fixation points. Because people want to print faster and faster, but then they have to also think about where is actually my center of gravity. You might have the lightest system, but if you fix it on the wrong end, you have a lot of momentum that flings it around.
Any last points you want to cover on this extruder before we move on to the last thing you wanted to show us?
Yeah, and one last thing is basically it's actually mirrorable. So you don't have to actually buy a mirrored version. Let's say you want to have the manual wheel on the other side and the gears on this side. You can just disassemble it, use the plate on that side, that plate on the other side, reassemble it, and then you have it basically switched around. And it doesn't also influence the center of gravity or anything. You have it instantly mirrored and you can change it any way you want. So it's not fixed in this kind of way, so you can change it.
So because it's all it's like flat parts, they're all symmetrically opposite, you just assemble it the other way around and then you got the mirror. That's really good, especially for those looking at like IDEX setups or other like dual extruder setups.
Exactly, so if you wanted to have basically if that manual wheel is on this side and you want to have a second extruder right next to it, you can mount that and you have the manual wheel on that side and then manual wheel on that side. Looks actually probably quite cool. I haven't thought of that, but yes, that's true, yeah.
Excellent. So what's the last thing you wanted to show us today, the last product you wanted to highlight?
Is the Omni Drop version 3. So the Omni Drop, went through a lot of development over the years now, and the first aim when I started working on this extruder was that the users should print their own parts. And I couldn't make it work because the gears were current on the earlier designs needed to be printed. And to get those gears printed correctly with a very fine nozzle and stuff like this made it a hurdle for the user, I think, and would also give issues if people printed it wrong and then say, oh, that design actually doesn't work. And I didn't want to get that kind of image out of there. So we assemble the extruders ourselves, do run-in procedures, make sure that everything works before sending it out. But that is not the aim of this extruder. The aim was that people can actually assemble it themselves, change it any way they want because they're 3D printed parts. And one of the advantages of having a 3D printer is changing everything around and doing something different. And that was so finally we get there now. So the gears are now going to be injection molded. And these parts will still be 3D printed, can be by the user. There will be a hardware kit. And as well, this one can be mirrored as well. All the parts are mirrorable, so you can also on the OmniDrop mirror everything. But you need to reprint the parts mirrored, obviously. So this is now possible for all the users to change this whole extruder around. The core functionality stays the same of the OmniDrop: short filament path, easy to load and unload filament, losing the manual wheel, flexible filaments. Is easy down to 60A. We have the ring gear. We finally have silicone socks that are injection molded, and also basically the same kind of thermistor what we have on the XG Hotend. So that is also the thing. So the system is swappable. If you have one thermistor on this one, you can use it on that one. That is not an issue. Part cooling fan is in there, which is optimized to cool everything down and use all the airflow from the whole fan, because some designs, use CFD, and even CFD doesn't assume that the airflow is consistent everywhere, which is not the case for these kind of fans. So there was a lot of just basically guessing and guesstimating to get everything right, to get the airflow just the way we wanted to. So there's a part cooling fan integrated on this, and yeah, so that is basically the last little announcement we have on this extruder.
Excellent. So regarding the 3D printed parts, obviously, if users want to print that, presumably they'd want to make sure that their printer is nicely dialed in and calibrated, producing the right size parts before they go ahead and start trying to use it. Otherwise, they may encounter some issues.
Actually, not that much. You don't need any more that kind of precision, since the gears needed the most precision. Those parts which you can print, if you have small little defect, will not influence the performance of the extruder. Yes, we will give some guidelines and to help you to get your print settings dialed in, to get those parts optimal, but it's a lot more forgiving. It's a lot more forgiving than the gears. The gears were like a real pain because you really needed to dial in down to the extrusion multiplier need to be just right, you need the temperature right, the layer height, the nozzle needed to be at 0.25 at maximum, just to get those gear profiles just right. So there were so many hurdles, and that is annoying. But with these parts, you can print it with an 0.4 millimeter nozzle, just standard, and you get away with small little, deviations and stuff. So that is not an issue.
So basically, you're taking care of the really critical parts, and the user can deal with the rest of it the way that they choose.
Yeah, and they can try reprinting it. These parts are quite small, and if something goes wrong, they're not happy with it, they're very fast printed again. It also, I assume that you're going to change, the step files will be available, you're going to fit it to different kind of 3D printers. There will be for the Ender and the Prusa already mounting options which you can print. But if you want to change your parts around for a different kind of printer we don't offer for, or have an STL5 for, you can change it. And probably on the first try, it happens to me a lot, we don't get things right on the first try, Or you notice something, you're like, actually I wanted to move it further, 1 millimeter further to the right or left, And then you're going to reprint the parts anyways, It's part of the fun, actually.
Okay, well, if that's all we're going to talk about today, I think we've covered most things here. So thank you very much for your time. Thank you for talking to me. I hope you enjoy the rest of the show.
Thank you too. Have a great show. Cheers. Cheers.